Hi folks, Mr. Long here. I'm going to go through a problem on revenue and profit and how we go about solving those types of problems. So first of all, let's take a look at the actual word problem. It says an auditorium has seats for 1,200 people, and the auditorium has been filled to capacity. So 1,200 people have been attending. They've been paying the 1,200 people attending have been paying $5. And the owner wants to increase the ticket prices. He estimates that for each 50-cent increase in price, 100 fewer people will attend. What ticket price will maximize revenue? All right, well, what I did is I prepared a table. And I would suggest for all these problems, you prepare a table. And this is just a suggestion on how to organize your table. The first one would be the number of price increases or price changes you make. And what is the price if you make that change, if you change the price that many times? And this is the number of people that attend. So you can see that initially at $5, 1,200 people attend. At if they increase the price once by 50 cents, 550, and 100 less people go, which makes sense, right? The more you increase the price, the fewer the people are going to attend, right? Then if you increase the price twice, that would be my puppy, our puppy. Sorry about that, folks. And then if you increase the price another time, a second time, it would go up to $6. And then you would then have a thousand people attending. Okay, so let's take this table now and come up with some equations because we know we want to maximize things. Let's see if this is a linear equation, a quadratic equation, etc. Now, if it's a linear equation, there's going to be no maximum, but let's see if we can come up with an equation. So I'm going to add a column and a row. And if I look at these things, three things that are changing. Oh, by the way, this is revenue. So revenue is how much money you take in. And so if I was to look at this, then what I would have is the revenue would be, let's see here, the revenue here, I would multiply the price times the number, right? It's how much money you bring in. So this would be 5 times the 1,200. Yeah, $6,000. That does make sense. All right, so that's our revenue column over there. And let's take a look at this. Which variable or which thing that's changing, which thing that's varying, should I pick as my x? Well, I've got something that's changing that's going 0, 1, 2. 5, 556, 1,200, 1,100, 1,000. Probably I need the simplest thing that is varying to pick as x. So I'm going to pick as x number of price increases. Now let's look at our next column. If this is x, then what is this column? Well, when x is 0, price is 5. So that means the y-intercept is 5. Okay, and it seems to be linear. It's changing linearly by 50 cents each time. Oh, what's the rate of change then? 50 cents per price increase. So 5 plus 0.5x. Okay, we got that. And then finally the number. Well, when x is 0 and there's 0 price increases, there's 1,200 people. And how is that changing? Is it increasing or decreasing? It's decreasing, so it's subtracting by, 100 per price increase. And price increase is x. Okay, so there we go. And then we know what we have to do over here. We have to multiply to get revenue. Okay, I have to multiply to get revenue. So here's what we're going to do. We're going to multiply that out. And what I'm going to do, folks, is I'm actually going to go into an app you're going to see here called Mathway, which you might want to use. And you still need to be able to do this algebraically, but let's take a look at this and see if I can multiply that out. 5 plus 0.5x, 1,200 times 100x. 5 plus 0.5x multiplied by 1200 minus 100x. Now, we put this in a little box and we expanded it out. There's lots of different ways you can do this, but in Mathway, which is free on your iPhone as well, or your Android device. And let's see, how should I answer? I want to simplify that. There we go. So all I did was select simplify, and it shows me that the answer is negative 50x squared plus 100x plus 600. Now, what I can do here, whoops, is take that and take a look. What's my A value and what's my B value? Okay, what's my A value and what's my B value if I'm to get the vertex? Negative B over 2A. Well, A is negative 50, B is 100. So let's go back to, whoops, not there. We'll go back to this due to math, and so I know it's negative 50x. Sorry, let me go back to that. Negative 50 and 100. Okay, so I'm going to put in a formula here. Negative b divided by 2a. Okay, so that is, and I'm just going to take a look at this again right here. So negative 50 is the a value. Double click on A and put in negative 50. Okay, and I'll double click on B, and B is worth 100. There's B is worth 100, and I'll hit OK. All right, so let's multiply that out, and I think we know the answer to that. Negative 1 over 1, that simplifies to 1, so I need to have one price increase. Okay, one price increase. That gives me the vertex. So if I have one price increase, that means I need to set the price at 550, and I'll have 1100. Okay, so what I would do then is, in my formula, I've got, the formula is 5 plus 0.5x multiplied by 1200 minus 100x so that right there would represent the revenue. And now I need to have x assumed as 1. So I let x equal 1. And when I multiply that all out, the maximum revenue is $6,050. Okay, so process-wise, let's take a look at what the process of that problem was. The process of this problem was read the problem, make a chart to describe what's happening. In your chart, your column titles are the variables, the things that are changing. In our case, it was the number of times they chose to increase the price, what the actual for the increase, and then how many tickets would be sold. So if we look at it, 0 is just your initial price and your initial number. One price increase bumped up the price by 50 cents, which in turn dropped the number attending by 100, and so on. And then you get a pattern from this. It's pretty clear to see that the number of price increases needs to be x, and then your price is 0.5 plus 0.5x, and your number is 1,200 minus 100x. So now it says a profit problem. Now suppose the cost per person for the auditorium to hold a show is $2 per person. Oh, sorry, folks. So that was the process, right? I didn't finish that. And then I actually, I took this equation right here. 0.5, I'll go back to the actual equation. 0.5 plus 0.5x, 1200 minus 100x, and I multiplied it out. I expanded it out, and I can actually do that even on this app, right? So I can expand that out. And then I can expand this out. And expand that 100 there. And that right there. And that there. And I can take this one minus of negative 100 is plus 100. So let's get the order changed. Okay, that's the expanded form then. That takes a lot of work to expand that out on there. But that was our expanded form. And then we had to do negative b over 2a, right, to get the x value of the vertex. And then we substituted that back into the original equation, which is this one here, or the factored form. Okay, and that got us the actual revenue. So now what we need to do is to look at what happens if we're doing a profit problem now. Well, what's profit? That's how much is left over from your revenue if you have a cost, right? So it actually, let's see what it says here. Now suppose the cost per person for the auditorium to hold a show is $2 per person. Oh, well, because they've got to pay for custodians, they've got to pay for people to work at the vendors, they've got to pay for electricity, they've got to pay for water, all kinds of different things. They've got to pay for rent, they've got to pay for taxes. So even though the people are paying $5, the auditorium costs them $2. So now, instead of just how much money do they take in, we have to look at how much money they take in versus as compared to how much money they're actually spending. So if you look at this, they cost $5 a person, and they're spending $2 a person. So how much is left over? Well, it's $3. So now all we have to do, instead of price per person, it becomes profit per person, which is going to be 5 minus 2. Okay. And instead of 550, that will be 350. Instead of 6, I have to minus $2 off that, and it will be $4. So instead of 5 plus 0.5x, it becomes 3 plus 0.5x. So instead of 5 plus 0.5x times 1200, it becomes 3 plus 0.5x. So you can see now that the only thing that changes is the $5 revenue per ticket changed to $3 profit per ticket. And then you just finish out the question and it's no different. Okay, so the only thing you're changing is that 5, you have to take away 2 from it to get 3. Okay, and then you would just repeat the process if it was profit. So you have to look carefully at these questions, whether they ask for profit or whether they ask for cost. All right, so that's how you do those problems, folks. And I hope that helped. I'm just going to turn this off now. Make sure you look at the video again if you need to.